I need a drink.
Yeah.
Okay. So yeah, the talks previous to ours outlined what like row calculus was and what RChain is aiming to do. And what we're going to do is give you an introduction to Rholang, the actual programming language in which RChain is written. First, a little bit about us. Who are we? My name is Ahsan, and
I'm Thomas.
Yes. And we're both full-stack developers, and yeah, there's not much information else of us out there. So we're basically the same person, only I spent a little bit more time in the sun than him. I'm going to talk about the basics of the Rholang syntax. Before we can actually start coding and give you code examples, we need to first know what the syntax is, what all the symbols mean. And yeah, before I'm going to do that, I'm going to give you, so that everybody is on the same page, I'm going to give you a little bit of an introduction or like a recap of how normal programming languages work. Normally you define a function, call that function, and the function gets executed sequentially. So here's a piece of JavaScript code. You define a function with an input. The input gets incorporated in the output, and the output gets returned. So this gives hello RChain. That's really not the case with Rholang. As we saw previously, everything is executed sequentially. In Rholang, everything is executed concurrently. Everything is essentially happening at the same time. Like if you're watching TV and eating a sandwich. And the symbol that indicates that is the pipe symbol, like the symbol in between those two things. So it's a really important symbol in Rholang, and almost every line ends with it. It's like a semicolon in other languages, only this is required. Yeah, next I'm going to talk about channels. Channels can send and receive. A sending channel has an exclamation mark behind it and gets executed, and then it's a channel that's actually sending something. A receiving channel is essentially a for loop, like the programmers under us know what a for loop is, and it receives from a channel. There's a distinction being made between one line and two lines. That's basically just if a receiving channel receives it once or all the time, like while the process is running. So putting those two things together that we just learned, everything is executed concurrently, and as channels can send and receive, we can create something like this, where the first line is sending something, second line is receiving, and both are executed at the same time. And because both are executed at the same time, we can change the order of this. And it doesn't matter, because everything is executed at the same time. I'm saying execute at the same time really a lot. Okay. So another principle in Rholang is matching. So if you have a piece of code and you have a receiving channel that accepts two arguments, x and y, and you have a sending channel that sends two parameters, hello and world, it gets executed normally. It's matched, as we call it. But if you just give one parameter to the sending channel, it won't execute because it's not matched. And you can even define in your receiving channels what kind of parameter you would like to receive. For example, here the first parameter needs to be hello. It's not. This doesn't get executed. But here it is, and it gets executed. Then we have named processes. This is a little bit vague to explain right now, but Thomas will like take it over and in the later phase to put this into code examples. So I hope it will be clear by then, but right now, just hold on. So the first line is a named process. A process, for example, in JavaScript, you define a variable with var x is 2, for example. The 2 is the process in this case, and x is the name of this process. In Rholang, the name is the process. So how do you pass a process, or how do you receive something on a channel without passing the whole process to it, but just a pointer to it? We can do that with an asterisk put in front of the named process. And then you can pass it into a channel. You must be wondering, how do we call that process and execute it? That's with an @ symbol before the name of the process. And the exclamation point or the bang says that it's a sending channel. Just to recap, Rholang is asynchronous and concurrent, and that's defined by the pipe symbol. You can send and receive on channels. Sending is defined by the exclamation point, and receiving is done with a for loop. You can convert between names and processes to use them as pointers or execute the process, and that's done with the @ symbol and the asterisk. So this is all you need to know for now. Am I missing something?
That's it. That's basically it.
So this is all you need to know right now, and right now it's super vague. If you come from like a normal programming background with non-concurrent languages, it's a little bit vague, but with code examples from Thomas, I hope it will be clear, and else you can ask us questions downstairs.
Just a side note.
Yeah.
It's the other way around. So star is.
Oh yeah.
Oh yeah, it is. Yeah.
We typo. Okay, so I'll blame it on a typo. I don't know. No. So yeah, it's the other way around. An asterisk is a process from name. @ symbol is name from process. All right, take it over.
Cool. So I'll actually show you some actual examples of using Rholang. So as you've heard by now, RChain itself isn't yet ready. There will be a testnet released this summer, and then the mainnet will be released at the end of this year. The release of the testnet, by the way, will probably coincide roughly with the developer conference in Berlin. So if you want to stay up to date on that, please follow RChain_co-op on Twitter. They'll tweet out all the details. So on the RChain developer website, you can find a great tutorial with a lot of code examples. And one of the first things this tutorial will tell you is that there are basically two ways to run Rholang code. One is installing your own RChain node. The other is using a tool Ahsan and I built called RChain.cloud, which is basically like JS Fiddle or JS Bin. Yeah. Which allows you to just enter some Rholang code, run it, and see what happens on the node. Really quick way to try and grasp the language without having to do any installing of packages or Docker or anything. Sure. So let's go into the default code example you'll see whenever you actually start up RChain.cloud. It's of course the hello world example, like everything. What it does is it defines a new channel called hello world in line 1. And then in line 2, it defines that hello world should be a process that accepts one parameter, namely name. What it then does is, the only thing this example does is output hello Joe. But you can't actually say first output hello and then output Joe, because everything in this language is concurrent. So the way that this is done is you create a new channel called ACK, which is short for acknowledgement. And you call this special system channel called stdout ACK, which stands for stdout with acknowledgement. Stdout is printing to the terminal. And it's passed two parameters, namely the string hello and then a reference to the channel ACK. At the same time, it also receives something on the ACK channel. And when it does, we know that the hello has been printed. So then it can print the second part, namely the name parameter we got before. While that contract is being put in place, we also actually execute it with the value Joe. So what this example does is it outputs hello Joe. Super helpful. Let's let's actually, to further understand this, because this is super simple, it basically only has one process that gets executed. See how we would implement std out egg if we would have to do it ourselves. You can't really, but just as an example, it would look something like this. We named it std out egg 2 because you can't actually redefine a system channel. And it has two parameters, the message and the channel that it should call back on. And the way we implemented it is we send the message to std out and at the same time call back to the channel. We send that channel, that callback channel, just the value 0, which is equivalent to null in PHP or JavaScript. Unfortunately, of course, std out and the callback will be executed at the same time. And then later on in this example, as soon as we get that callback, we'll execute another std out. So what this actually does is it outputs Joe hello. Or it could basically output any of them in any random order. It just happens that calling back to a channel or sending a message to a channel is apparently faster in this implementation than printing the std out, which causes the second std out to be executed before the first one. Let's go into some details that have been discussed before, but actually show them in code. One of the fun things you can do with Rholang is that even though it looks nothing like any object-oriented programming language you've ever used, you can actually do something that's quite similar. For this, I borrowed some code from Rinke and then mutilated it because it was too long for a single slide. So what this does is it defines a process called calculator, and that contract takes one parameter, namely red, which is a channel on which basically you can see calculator as an object here, if you were to use object-oriented terms. And what the first line of the contract does, so line 5, is call back with an instance of this object. It's only terminology I'm using to explain it because that's not actually what's happening, but it might help to show the similarities. What it then does is it listens on the channel that we send back in the callback for a specific type of argument, namely 4 different arguments, where the first one is equal to the string sum, and the second 2 can be whatever you want, but for this to work, they have to be integers. So when we actually then call this contract and get back an instance of the object, we can call it object with the string sum, 2 integers and a callback, and the sum method will be executed. So that's quite neat for people that come from object-oriented programming to kind of try to understand this language. Something else that's pretty fun is that it's based on a lot of built-in security principles, and it makes it really easy to implement the principle of least authority, which basically means don't give anyone more access to data than they need. And there's a few different standard utilities you use basically to implement that. One of them is called revocable forwarder. It's one of the simplest ones. You could compare this to trying to sign in to Spotify with your Facebook account. Once you do that, Spotify gets access to your Facebook account, but only until you click the revoke button in your Facebook settings. And it's actually pretty easy to implement something like that in Rholang. It's only 17 lines. And this example is on the Rholang tutorial as well, so feel free to check it out there. And then you can implement it by calling that contract that we created in the previous slide, make revocable forwarder, and basically get a tool that allows you to control access to a certain object without giving like free range, unlimited access. There's way more examples on the developer website. most of them have a button to immediately run it on RChain.cloud so that you can actually see what happens. So yeah, I urge you to check it out, give it a try, and if you have any feedback for RChain.cloud, please let Ahsan and me know.
Yeah.
Thanks.
Thank you. Questions?
Yeah, any questions?
No questions? All right. Oh, there's a question.
There you go.
A burning question, actually. Sorry, I have no developer background. I'm more on the business and the functional side. I just would like to know, in your development environment, what kind of use cases you cover. Maybe I missed a part in the start. Sorry, I wasn't here.
Well, you can basically build any type of blockchain application with this. These are just really simple examples because it's hard to actually build something super useful since we don't have a testnet yet. So we can build a smart contract and run it locally. That wouldn't really bring us much. So until that actually gets released, we won't get much more complex things than this. But you can basically build any type of blockchain application that you can imagine using this syntax. I hope that answers your question.
Partially, yeah. Thanks.
Sorry. And not only blockchain applications, but Rholang in itself is just a normal programming language. So you can build everything basically.
Oh,
I have a question as well. Can you tell us how you came up with RChain.cloud?
That's actually a question you can
yeah,
take yourself.
yeah, dude. Okay, so yeah, we were at the RChain Developers Conference in Boulder, Colorado, a few weeks ago, and we hadn't heard from RChain ever before that, and within one day we wanted to get started, get the environment up and running, but there were some limitations. For example, if you run Windows, that's not Windows 10 Pro, you can't really get playing with it without a lot of setting up. So what we thought is, why not run it in the cloud, and have a public URL that anyone can visit, and just create an instance of a node to execute your code on. And that's what we built in the hotel room while we were at the conference, and just to help people get started with RChain.cloud.
Yeah.
Or like
only
with RChain.
negative effect of that was that we missed some talks on consensus and still don't understand it at all.
Yeah,
But at least we are able to run Rholang now.
Yeah, exactly. And as a last note, if there are no more questions. Okay, there's a question.
This is maybe an out of scope question, and also Philip maybe can answer that, but it's a thing that is nagging me a little bit the whole time. The standard out channel. Yeah.
Yeah.
There's a reason why Ethereum does not do standard out, and this is why, because then the locks are not part of the consensus and you can forge them. So will this be part of the Rholang thing or not?
It will definitely not have any influence, I think, on consensus. It's more just a development tool right now, because otherwise you wouldn't see anything happen at all when you run a Rholang smart contract. So I don't know how it is being handled in consensus, but maybe it's probably even removed when the mainnet is launched, I'm guessing.
Yeah, that's what.
Because yeah, it's not the standard part of the Rholang language.
Okay, thank you.
Okay, no more questions? Okay, question there.
So, so when you learn about a new language, one of the first things you want to know is about the types. Didn't see anything about the types in this thing. Like in Solidity, you have crazy types, like you specify bit sizes and things like that. Here's nothing like that. Is there?
I think it's quite limited right now. I actually didn't realize that it already supported strings until I started playing with some of those examples. I think it's still being expanded, but it will stay pretty standard within the normal Java and Scala type system, I think. I'm guessing. probably, Philip, you can give a better answer.
I hope it's not gonna. Yeah.
I think the language is in very rapid development, so it's changing probably even faster than Solidity is changing. So yeah.
So we'll know when the mainnet launches and a more stable version of the R node is released. Yeah.
And at the beginning, it seems quite intimidating, but I would just recommend to go to this URL and do the tutorial. It has a weird, it doesn't have a steep learning curve, it has a weird learning curve. That's like a roller coaster, so you're frustrated and like feeling like the king of the world 2 seconds apart. So yeah, I would just recommend start playing with it. That's the only way to learn, and you will be ahead of everybody else if the mainnet launches and the first stable version is live. Thank you.